So my name's Tim Lanfear, and I manage Nvidia's European Solution Architecture Group. So it's a team, an engineering team, a technical team that supports all of our Nvidia's enterprise solutions. I want to talk about two things today. First of all, I want to talk about what is the most recent and key and hot activity in the area of GPU computing, where we're seeing the biggest business opportunities for GPU computing. And that is in the area of artificial intelligence and deep learning. And then after that, I want to talk about how you can take advantage of that GPUs for deep learning within the context of the OpenPOWER architecture and OpenPOWER framework. So I think previous speakers have mentioned their OpenPOWER credentials. If I've got it right, Danny, I think that Nvidia was a founder member of OpenPOWER, so we've been in it right from the beginning, working together very closely with IBM. So the way I'll talk about artificial intelligence and deep learning is actually by not talking, but by showing a video. I'm sure by the end of the afternoon you've heard enough people talking, you've had enough slides, and it'd be more entertaining to see a video. This is a video that was shown as part of the keynote presentation of our recent GPU technology conference in California. So I hope this is going to work.
It all begins from a single origin, a unique point in space and time. This is the spark of innovation that fuels your most amazing breakthroughs. It's a passion for discovery that unveiled the genesis of all that exists in the universe. Today, the power of AI helps computers achieve superhuman capabilities in image recognition and lets scientists save our most precious resources by analyzing in 1 month what used to take 10 years.
是谁发明了机械计算机？
Everyday devices translate even the most complex languages from voice into text and images into words.
Xavier is now present.
Helping the visually impaired recognize an old friend, or letting a blind woman read to her child for the first time. Autonomous vehicles give us the freedom to reimagine our city streets and travel where there are no streets at all to help the lost find their way home. We see robots teach themselves to perform simple tasks. We even watch in awe as they take their first steps. And today, a 2,500-year-old game meets its match as a computer competes with one of the greatest human champions of all time and wins. This is the collective imagination, fueled by forward-looking technologies and the beginning of your most amazing discoveries yet to come.
Now you might know Nvidia, or is probably best known as a company that produces graphics cards that go into PCs so you can play your video games. But the company does reinvent it from time to time. First of all, it went into enterprise graphics. About a decade ago, it started the idea of using a graphics processor for numerical computation, and that was when I joined the company. And then most recently, it's now positioning itself as the artificial intelligence computing company. So all of the effort, large amounts of effort inside Nvidia is being placed upon deep learning, machine intelligence, artificial intelligence. Now I've heard the CEO of our company, Jensen Huang, say, Nvidia is going all in on artificial intelligence. And when our CEO says something, you can be absolutely sure that the 10,000 employees of the company will follow that. And the reason is that if you don't do what he says, he is an extremely scary guy. And you will very quickly start doing what he wants you to do. And so as a consequence of this strategic decision from the top of the company, Nvidia is investing heavily throughout the company in deep learning and artificial intelligence. And the reason for this is we found that the GPU is the ideal computing platform for doing the sorts of computational work that's required for this task of teaching the computer to interact with the world in the same sort of way as human beings do. So these are a couple of the two or three of the key moments within the development of the GPU as a computational device, not just for doing computer graphics, but as a device for general purpose computation. And several times we have now appeared on the front cover of Nature magazine, which is surely the leading source of the leading scientific magazine within the world. And so what we've got here on the far left-hand side, we have an analysis of a key bacterium that was related to the HIV virus. So an analysis of how a model of how the HIV virus is working. And then we have two others which are related to this theme of artificial intelligence. And in particular, the one on the left-hand side is reporting the case where the computer has finally been able to master the game of Go. IBM, a decade or maybe it was even longer ago, managed to master the chess game with their I can't remember the name of the system, but their Deep Blue. Thank you very much. I'm sure there are a number of IBM people in the room who can remind me of it. The Deep Blue system mastered the game of chess. It took a little longer, but now we have also computers that can master the game of Go, because the experts were actually consider that Go is actually a much harder game to manage than the idea of playing chess. How does GPU acceleration work? So the GPU is a co-processor. So much of your code will continue to execute on the CPU as before, and this, of course, it can be any sort of CPU, but of course including IBM Power CPUs. And what we have in the architecture is a combination of devices, a combination of processors, where we take advantage of the strengths of the processors within the system. So we have the CPU is characterized by a modest number of relatively powerful cores. And so it's good when you have pieces of code that have relatively less parallelism within them. Whereas the GPU on the left-hand side of the screen has a very large number of lightweight cores and is relevant when you have a high degree of parallelism within your code. And so by distributing your code, your application between the two classes of processors, you can get the best of both worlds and have the two classes of processors working together on the more parallel and the less parallel parts of your application, so as to get overall the best possible throughput. But it's not sufficient just for Nvidia to produce a piece of hardware and hand it over to the users and say, here you are, please get on with it, write some applications. Because actually a piece of hardware sitting on its own is only a small part of the story. What you need is as well as the good processors, and the GPU processors are characterized by two things. One is a very high floating point performance, and the other is the very high memory bandwidth. But of course, you also need to go along with that all of the tools that the developers need. And so you might believe or imagine that Nvidia is a hardware company, but in fact, the majority, I believe it is the majority of our employees are working on software, because we have to develop compilers, libraries, debugging tools, profiling tools, and so on. So there's a vast amount of software work is going on inside Nvidia, making sure that the developers have all the tools that they need. But as well as all of the tools, we also have within our company a number of domain experts. So we have people who know about CFD, we have people who know about quantum chemistry, we have people who know about quantum mechanics, molecular dynamics, CAD modeling. And so we can work together with both the users and the developers of new platforms to ensure that they have a platform that suits the requirements of the GPU and is the most performant system. And then finally, of course, we want people to have access to the platforms. And IBM SoftLayer cloud system does indeed offer GPUs to users today, and there are many others as well. So the latest product coming from Nvidia, which works, and I'll show you how you can deploy this GPU within the context of power processors very shortly, is the Tesla P100. So this is a new architecture. IBM was very deeply involved with the bring-up of this system and the design of the system, because one of the key characteristics of the Tesla P100 is this second box, which is NVLink, which is a high-speed bus that allows you both to transfer data from one GPU to another, but also between the GPU and the CPU. And IBM is the company that had the foresight to know that it's very important to have a high-speed interface between CPU and GPU so you can move data quickly between the two processors within the system. And so IBM engineers were at our site on the day that we got the very first samples back from the chip foundry, and just a few days later I think they went away with a few samples of their own so they could then start seeing how well the Pascal GPUs would integrate within the IBM Power Platform. What else have we got? We've got a couple of things here. We've got a very high bandwidth memory system. So GDDR5 memory is pretty much running out of steam. But luckily, the next generation of stacked memory is coming along to replace that. And then finally, we have some extra aids to help the developer port their applications to the GPU platform. So the GPU, the Pascal P100, is available within the Minsky servers. You can have up to 4 GPUs within this platform. As I said, IBM had the good foresight, the good engineering understanding that tight coupling between the GPU and CPU was important. This Minsky platform is now available for sale, and would be a good way for people to get hold of GPUs and start using them. And I know that there are a number of people within the OpenPOWER community who are already starting to have had, I see one here from SDFC, I think, already have some systems here available. So that concludes my presentation, so thank you for your time.